Okay, so this is my Blasteroids application, and I'm going to show you some of the basic features of it. Alright, so the first thing that we notice is that my blaster is actually being attracted to the asteroid by gravity. Each object in this game has its own mass, and with this mass we can see that I am being pulled in the direction of the asteroid. This is just normal gravity. The integration that's used for this is actually a Runge-Kutta integration, which is a form of numerical integration, and it's very fast. And as you can see, there's almost no lag going on here. Actually, there isn't any lag for this situation. Alright, so that's it for the wrapping. The blaster has some basic maneuvers, such as it can fly. So if I hold down the W or the up key, it will thrust in whatever the direction that the blaster is pointing in. If I hold down the D or the right key, the blaster will rotate to the right, and using this I can turn as I'm thrusting. Similarly, I can turn to the left. In order to slow down or to stop, I actually have to turn fully around and use my thruster in the opposite direction. One of the things that we can see here is that when the item is wrapping across the screen, the gravity actually stops working for the wrap, and it pulls it in the opposite direction. This is something that could be fixed later, but it wasn't a priority for this round. Also, let's take a look at the wrapping here for just a moment. Let's see if I can get this up to the edge of the screen up here without being pulled too much by gravity. Okay, as we can see, we see that my blaster is in the top right, the top left, and the bottom right. This is due to the wrapping. So whenever you go across one side of the screen, you actually come across on the other side of the screen. So that takes care of all of the wrapping for the blaster, the Blasteroids, and yes, I'm calling them Blasteroids because this is a ripoff of the Asteroids game, obviously. So I'm just following suit with that. If I press the spacebar, you can see that I can actually fire off a large amount of bullets. That actually is a finite amount, as in I could set the amount to only 10 bullets, so that only 10 bullets could be active on the screen at a time. This prevents the user from spamming the field with lots of bullets, so that they destroy everything in sight. That would last, the bullets are set to last for about 1.5 seconds right now, I believe. As you can see, if I fire one bullet off, it dies right about wrapping on the screen later. So the bullets have their own lifespan, but they can also be fired. You can see that the graphics that I chose for this are actually reminiscent of the original Asteroids game. It was a bonus to use a different graphic set, and I thought it'd be cool to use the original Asteroids. So I actually found sprites for the asteroids online, and actually each asteroid is one of 3 random sprites. So we can see that that those are actually a little bit different. The actual blaster I made myself. I looked online for some different inspiration, and I wound up making this one because I couldn't find an actual sprite sheet. So another thing that we can see is that, well, you can see them wrapping around there, but you can also see that there is no collision detection right now, so everything is just going to pass right through each other, and that's okay. Let's take a look at the settings, and I can kind of show you what the settings are doing. So here we can actually see that we have a settings class, and the settings class has the basically it's just maintaining a dictionary for us, but with easy setup and easy calling. So we have a directory settings, and the directory has an assets directory and an images directory. We use a screen settings for a width, a height, frame delay, vectors, and we can actually see the two ways to initialize the settings here. Here we use a constructor to initialize it. Python doesn't have a new keyword, so that's actually not the way to do it. You just call it like you would a normal function. We also have settings for each of the sprites. We can see that we have a Blasteroid settings where we set the count of Blasteroids, whether or not that count is a random amount. So if we set it to 5 and then random amount to true, we could have anywhere from 1 to 5 Blasteroids flying around. We can set the maximum mass, and then whether or not that mass should actually be random. So if we have the maximum mass set to 5,000 and random mass set to true, that means that we could have anywhere between a mass of 1 and 5,000. We also have an initial velocity and a maximum angular velocity. This basically just says that the Blasteroid cannot go any faster than 50, and it can't rotate any faster than 2.5 meters per second. The file name for the Blasteroid, we can actually see that there's a list of file names here. There's, in the images directory, we see that we're looking at Blasteroid, Blasteroid 1, 2, and 3.png. This X range right here actually says anywhere between 1 and 4, and 1 is inclusive, 4 is exclusive, so that means that we're actually looking at 1, 2, and 3 there. Okay, we have some similar settings set for the blaster. Display basically says whether or not to display the blaster. If we set this equal to false, like I'm going to for our next example, then we only see the asteroid floating around in space. The bullet count is how many bullets we can fire before we have to wait for more to expire before we can fire more. The mass is just the mass of the blaster. The thruster acceleration is whatever the acceleration should be whenever we're actually accelerating at the time. This is set abnormally high right now just to kind of get a feel for everything. We could set that back down to 100. The thruster dampening is whenever you're thrusting, if you stop, you're going to slow down, and your velocity is going to basically be multiplied by this 0.999 until you've slowed down so much that you're no longer accelerating due to the thruster. You may be accelerating due to gravity and another asteroid, but the thruster won't be causing you to accelerate anymore. Rotational acceleration is similar to the thruster acceleration. It just sets whatever the rotational acceleration is for whenever you're holding down the left or right keys. The dampening is also similar. It means that we're going to stop eventually when we're rotating. We don't want the blaster to rotate indefinitely. The max rotational velocity says that we can only rotate at this speed, and I have it set to 10 times math.pi, which is just 10 times the value of pi. And that was just after some tinkering around until I could find something that I liked the most. The maximum velocity is set to 1000, and again that was just after some tinkering. The sprite is set to use the blaster.png file in the images directory. I would show these files to you, but it's white on a transparent background, which kind of just shows up as white on white, so you just have to be able to see it in the actual application. Alright, so bullet settings is similar as well. We set the mass, and we set the initial velocity, and we set the time to live. Now the bullet's velocity is actually going to be affected by the gravity around it, so the initial velocity is not necessarily what its maximum velocity is. I don't actually set a maximum velocity for it. The other settings are the gravity setting and the general. There may be some other general settings to add later on. Right now there's just gravity. I actually have gravity set abnormally high right now. This is just to kind of see what the physics is going to look like, and we could turn this down and you would see what that looks like under more normal settings. So the other thing that I've set here is the keys, and we have the thrust key set to the up and the W key, the rotate right key set to the right key and the D key, rotate left set to the left key and the A key, fire set to the space bar, pause set to P and the pause key, and quit set to the escape key. Alright, let's do some tests of the system just to see what that kind of looks like. Let's set the maximum count of Blasteroids to 20, just to see what that looks like. And let's go and run that. Alright, so as you can see, there are different... Let's go and pause that. As you can see, that there are different Blasteroids hanging around here. There's this one right here, Actually, right along the center, you can see all three Blasteroid files. You can see that when they overlap, they are indeed transparent, and there's nothing to help them there. But you can also see gravity kind of pushing and pulling. It's a little difficult to see gravity working in that one, actually. There's too many going on. Let's bump that cap down to something a little bit more reasonable, like 3. And here you can see, well, that was a little bit, as you can see, it gets a little bit crazy whenever they overlap at the exact same point. But other than that, gravity tends to take over, and we can see that everything's wrapping and everything's being pulled in the right directions. If we set gravity to something insane, like 15, everything starts behaving a lot more erratically. Everything's being pulled in a lot more interesting of a manner. But this would not be suitable for gameplay because the ship would constantly be being pulled in by gravity. So let's set that back to 2. That's basically all of the settings for this application. It's how everything runs within the application, and I hope you enjoy it.